Welcome. In this video, we are going to take a brief look at how Bohr came up with his theory for hydrogen. Let's set the stage first. It was established that substances are made of atoms and that atoms contain electrons which carry negative charge and protons which carry the positive charge. The current model of the atom was Rutherford's planetary model, though it did have some problems such as accelerating electrons, which would lead to unstable atoms when using classical physics. It was also a mystery as to why the atomic linear spectra were discrete. Discrete line spectra mean the energy states that produce them are quantized. Bohr proposed an equation for calculating the wavelength of line spectra in hydrogen. This equation is an empirical formula that fits measured data. Nf is a positive integer. Nf equals 1 gives the Lyman series. Nf equals 2 gives the Balmer series. Nf equals 3 gives the Paschen series. And there are more series as well. Ni is a positive integer that starts at nf plus 1, and it can go up to infinity. Now note that 1 divided by a very large number is 0. We will see that Bohr will explain how this equation works in another video. Bohr came up with his solution for hydrogen in 1913. He began with Rutherford's planetary model. Next, he used Planck's idea that energy levels are quantized and that allowed energies correspond to electron orbits. Bohr also assumed that an electron in an allowed energy state, also called a stationary state, though that doesn't mean the electron is stationary, just that it doesn't radiate. Bohr also used Einstein's photon idea, specifically that a photon is given off only when an electron goes from a higher energy orbit to a lower energy orbit, and hence energy transitions are quantized. Bohr assumed angular momentum is quantized. He assumed that it is the Coulomb force that keeps the electrons in orbit, in a circular orbit, and that the atom is most stable when the electron is in the lowest energy state called the ground state. The energy is given by H times F equals E sub I, the initial energy, minus E sub F, the final energy. Here is a diagram from College Physics 2E by OpenStax, showing a few of the allowed energy orbits along with a transition of an electron from a higher state to a lower state, resulting in a photon being given off. Energy level diagrams are used to display energy states. N equals 1 is the ground state, which is the lowest possible energy state for the electron, and all other n values are excited states. Bohr assumed the electron orbits were circular and proposed that angular momentum is also quantized. Here we have m sub e is the mass of the electron, v is the speed of the electron, r sub n is the radius of the orbit n, and h is Planck's constant. L is equal to m sub e times v times r sub n comes from L is equal to I times omega, where I is the moment of inertia, and for a very small object, I equals the mass times the radius of the circular path squared. Omega is the angular velocity, and it is equivalent to the linear velocity divided by the radius of the circular path. Making the substitutions gives L equals m times v times r. I'll derive the equations for the Bohr radius and electron orbital energies in another video. In summary, Bohr was able to explain the spectrum of hydrogen, which we will see in another video that will be linked. He calculated the size of the atom via the Bohr radius. He proposed that electron orbitals, along with angular momentum, are quantized. With his model, the electrons don't spiral in and collapse. He was only able to explain hydrogen, so we will need another model, and it will be quantum mechanics to the rescue. I hope this was helpful. Let me know in the comment section if you have any questions or if there are other problems you'd like to see me solve. Thank you for watching. Please like and subscribe, and I'll see you in the next one.